Yes, no so far? So that's 10. Let me give you one and have you change it back to standard notation. They got this? Smell your stuff? I always worry when you sitting there because I feel like I'm blocking you. Because they say I make a better door than I do a window. Wouldn't that be scary? You made a better window than a door. People see right through you. Okay, so what if you have, I don't know, 9.6, okay, times 10 to the negative what? Okay, well, if you're not gonna help me out, I'm gonna help myself. You're gonna work for it. Right, Belinda?
Yeah.
Didn't want you to think I didn't notice you were sitting way over there in Report County. Have you got sandals on?
Bro. Why are you embarrassing me?
I'm just asking. Who else has got? Anybody else got sandals on? Without any socks? Oh my God! You got sandals with socks, and it's two different color socks. And I don't know, Gio, are those considered? Are Crocs considered shoes? Sandals somewhere in between. It's their own category. Okay. Okay. What's this going to be as their regular number?
I kid you not, that's how they just Crocs. Gotta go up right now. Why do my shoes like this and that? Like you move forward.
What's it going to be?
I would just one number.
Well, we know the 9 and the 6 are there, right? And we know from the negative exponent, it's going to be a really small number. How much math have I done so far? None. So I know it's going to be 9 and 6. And I know it's going to be really small. This said, yeah, I moved it 12 places. So move it back. Now, which way makes sense? To the left or to the right? How many rules have we quoted so far? About the only one is a standard form. I all the time have, well, which way are you supposed to move? I want to memorize which way you move it. It depends. Do you notice that if you're going from standard to scientific, you move it one way, but if going from scientific to standard, you move it the other way. So just ask yourself what makes sense. This means it's a really little ass number. What way do you have to move it to make it a little number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And fill in your zeros. One advantage to the little numbers is you don't have to put commas in.
But what's the difference between standard and scientific?
Standard is a regular looking number. Scientific is the funky one that's with the power of 10 in.
Oh, okay.
Now, make another note too. Because this drives me nuts on the test. You have to have the times 10 to some power. I have people do it. I'm going to show you what some people do here. Well, I guess I got to show you when we do another scientific notation. What they would do is something like this. If it was, oh, I don't know, 350, they'd write as 3.5. You moved it 2 places to the second power. Do you see what's wrong with that? This means 3.5 times 3.5. Would you agree that 3.5 times 3.5 is not 350? But I'll have somebody do that on the test. You have to put in the 10 part. Now it makes sense. So make a note of that. Don't be that one person, because somebody always does it. Okay. Where was I at? Oh, 3.5 What'd I say? 0.152 times 10 to the negative what? Okay,
Okay.
6. Well, I mean, I'm already using a 5. You know me, I don't like to use the same number twice. That almost makes me want to change my mind, but. What's this gonna be then, in standard notation? We know it's gonna be little. So we know we're gonna have the 30152. And we move the decimal place 60 times, right? So just move it back. 1, 2, 3, 4, 5, 6. Now, there is a little shortcut with these little numbers that was not true in the big numbers. Does anybody see it? Braden, you got it yet? I gave you hints right there.
What I think is you end up subtracting or adding the number that's on the left, the farthest to the left, to the exponent, since it's a negative.
I'm gonna just,
So -6 plus 1 is -5, and there's.
But where's this 1 coming from?
There's 1, 3 to the left of the decimals. Maybe?
You're on the right track, yes, but you're putting it very, very awkwardly. How many zeros?
5.
What's the exponent? -6. How many zeros? 11. The exponent is 12. The number of zeros with the little numbers only is always 1 less than the exponent, or rather the absolute value of the exponent. Because one smaller than -12 technically is -13, isn't it?
Yeah.
Why is that? Go back and look at the other ones we did. I don't have them on the board here anymore, but look back at the other ones we did just before this. Is that pattern not still there? Why is it true here that it happens every time, but it didn't happen with the big numbers? Nope, sorry, Janelle, that's not it. Nice try, though. Anybody see this? Why is it true here, but this little shortcut didn't exist with the big numbers?
Because and the decimal 3 is closer to decimal point, all the other numbers are.
What's that got to do with it?
And then they can count off to 0, and bigger numbers like separate the way from decimal. You have to count on the other numbers.
Anybody else
It
want?
makes sense.
I think you're dancing around it. Let me put it in more plain speech. Notice with the little numbers, only this first one gets jumped. When you had the big numbers, if this was 30152 with a bunch of zeros after it, how many? That part's still the same, right? But when you're moving it, 1, 2, 3, 4 of the spaces were taken up with numbers, and the rest of them are zeros. With the big numbers, the number of zeros is dependent on how many numbers you're keeping in your answer. But with the little numbers, it's always 1 and only 1. Because we're working our way back to it. We're starting from here, we get back, boom, after the first one we stop. Here, We're moving. We had to jump over 4 of them before we got there. Like so many other shortcuts, if you see it, great. If you don't see it, that's okay. Now,